Welcome to the J&T Explorers Show. I am Josie, and today we'll be talking about plant evolution history. So we'll be talking about bryophytes, pteridophytes, gymnosperms, and angiosperms today. But before we get to those, let's talk about green algae, which is kind of the evolutionary predecessor to those four groups. So green algae are typically unicellular and have flagellated gametes, which means that they need water to be able to reproduce. And without water, they dry out and die. So for our first group, the bryophytes, I have some brocade moss here on this fallen tree. So coming from green algae, bryophytes have a few different adaptations, the first of which being that they are able to live outside of water, unlike green algae. Mosses absorb water from their environment, so they don't have to live in the water, which is really great. They also have these little root-like structures called rhizoids. You can't see them super well, but they're kind of running like all in here, and it helps them anchor themselves to their substrate, so like this tree, for instance. And the third is that mosses exhibit alternation of generations, and they're gametophyte dominant. So when their sporophyte structures begin to grow and they are ready to spread their spores and reproduce, their sporophyte structures are much smaller. And this helps protect their gametes and spores from, being detected by predators and gives them a little more protection. For our second group, the pteridophytes, I have some ferns here. So different from bryophytes, pteridophytes also exhibit alternation of generations, but they are sporophyte dominant instead. And their sporophyte dominant structures are, the typical fern structures that we're used to, and they're able to grow much taller than mosses, which gives them better access to sunlight for photosynthesis. Another adaptation is that a lot of ferns will spread their spores through the wind, which allows, they're moving away from that reliance on water, so they don't need the water to reproduce, but also spreading your spores by the wind helps take them further, and you get more genetic variation in your populations. And thirdly, these guys have vascular tissues. They have xylem and phloem, which allows them to transport water and nutrients throughout their plant body. And it also, because of that, they're able to store water better, so that's also better for them.
All right, let's talk about gymnosperms now. I'm here at the beautiful Boone Creek here at the entrance of Durham Park, and I'm here with this huge eastern white pine. Let me go stand beside it so you can see how big it is. So what made these guys and all gymnosperms special compared to their predecessors? Let's find out. Okay, first point about these guys. They have seeds, so we can allow wind to disperse them. We no longer have to rely on water. Seeds are also the tree's way of protecting the embryo. Also, it provides food for it too. So we're getting way more evolutionarily efficient with these guys. All right, second point, we've now got pollen. I'm probably gonna be sneezing all over the place after being here because this is a huge tree. Pollen grain houses the male gametophytes, and once they, through the wind or whatever, make their way to the female structure, a pollen tube can grow, and that's that. Okay, final point. Upgraded vascular tissue right here. What do I mean by upgraded? Well, just have a look. I mean, these plants are able to grow really tall. They can transport nutrients and store food, all of that within the trunk. Oh, there's a bumblebee. I can also help them for competing with sunlight because they're so tall. It also helps with structural support. This thing is not going down anytime soon. All of this is like any other group before them. Okay, let's talk about angiosperms now. I'm outside of Watson Brummett Hall right now with a very beautiful pink azalea bush. So let's talk about these guys. Well, first off, we got flowers. I mean, everybody thinks they're pretty, and so do birds and bees and other animals that are pollinating this thing. Being able to use animals and insects to pollinate is a huge step up from the gymnosperms who could just use the wind and stuff like that. Second point about angiosperms is that we got fruit. Fruit protects the seeds and helps with dispersal. Well, how does it help with dispersal? Well, fruits are very tasty and animals love to come and eat them. When they dispose and lay their waste, the seed is not digested, so it's laid in the ground with a nice pile of fertilizer. My third point's a little more complex, but let's talk about it. Double fertilization. So now when the pollen tube goes down the style of the flower, one sperm may fertilize the egg to create the embryo, but the others are going to fuse with surrounding nuclei to create what's called the endosperm. So that will provide food for the embryo. This is huge in the way the plant conserves its resources. It's a solid upgrade from gymnosperms in terms of resource management. Okay, side note, this plant is like really pretty though. Booyah, and that was Angiosperm.